Hey everyone, we are streaming again, third stream today, and I want to start with presenting the frame we just did in an early stream. So let me just run by what we're going to do in this stream. If you check top right corner, we're gonna start with a frame presentation, then we're gonna present the idea from D&H to use a dividing head as a timing clutch. Then it will be CADing the loop wheel, CADing the dividing head, CADing the lock pin inside, CADing the pulley, mount to frame and to the assembly, and then we're going to be done. I'm here with my friend Hannes 3K. How are you today, Sir 3K?
You know what? Tuesday afternoon. Brilliant work has been done today. Let's finish this off with another epic CAD session. I'm ready to go. Let's head into CAD.
World's most eminent hype man and world's most patient marble machine builder in a stream together with you, the Gretzky's in the chat.
What could go wrong?
So, this is the... it's very, very sketched frame. This is not how it's going to look in the end, but this is an example frame. And it's a parametric model, so this is where we started. And the key point here are these brackets, because this is the simplified way to attach the programming wheel and down here, the loop drum to the frame, to the Marble Machine X. So check this out. There comes the programming wheel.
Ooh.
So you can see that the programming wheel is just hanging in this nice little bracket like this. And in this stream, I want to create the lower wheel, the loop wheel, because if we look at the loop wheel we have, it's the old version with this coronavirus turning thing. And it's not hanging, and it's not good, and it's not nice. So I want to make a copy of this, make it smaller, and put it down there. But just to show you a little bit how this looks. And don't be worried, this frame looks a little bit like a coat rack right now. And since we're doing form from function absolutism is the design language, maybe we end up with a coat rack. So let's just see if I add the other parts. Here's kind of the instruments. We have me over there on the left side, and then we have a drivetrain over here. So that's where we are at the moment. So that's the frame. I want to hang the loop wheel down there. But first of all, I want to show the presentation from D&H. We actually came up with this idea. Immediately when I saw this, I was like, yes. Because I used another part. Let's actually go back to CAD a little bit, Hannes. So I used this little thing for indexing the timing clutch. On the Marble Machine X, we had... this was not intentional.
But it will, though.
On the Marble Machine X, we had this brass indexing timing clutch. And I want to have a much better version of that. And I made this design in one of our streams. And it was indexed from this side, from the top. And then we can check at the idea from D&H, because it replaces my idea. So dividing head style, timing between programming wheel and shaft. And I was like, yes. When I saw this, it was right away, I knew that this was exactly what we needed. So I am going to incorporate this idea from D&H straight into the Marble Machine 3. This is why I love making a digital project, because I can actually act on good advice. So let's get to the next point. Let's first play a mole for the first 2 points. Yes. CAD loop wheel. Okay. So first of all, I want to start copying the top wheel, and I already prepared that like a cooking show.
Ooh.
So let's get into it. Hope everyone is doing fine, and we are on a roll today.
I just say like Dakota Grandin Strelo, CAD hype. Yes.
Yes.
And later on, Martin, you will have to explain to all of us what this indexing is all about. What does it do?
Okay, good point. not later, right away.
Let's head into it.
This wheel will drop marbles. This wheel is playing these drum beaters on the drums. We need to sync the two wheels with each other, and we cannot only have one setting because in different tempos, the latency will be different. So if they were synced in 80 BPM, they would be slightly out of sync in 120 BPM. So what this indexing thing will do is that we can make a setting so the two wheels are synced in all musical tempos. And since we're going to take these wheels off, so the way we're going to do this is that we're going to take the belts to the side like this. And then we're going to lift the programming wheel just off like this. Boom, 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 boom. Take it away. And in here comes the new reprogrammed programming wheel, just slotting it in place and putting the belt back. And we're going to do the same for this. And this indexing you can do off the machine while you're reprogramming the loop drum. So, and another good thing with this is that for transportation, since we also can remove these kind of stuff, all of a sudden we can take the things off for transportation, and the footprint, doors and stuff is much smaller. So that's a great idea. Actually, Hannes 3000's idea. So this thing is to sync both wheels at all musical tempos. And I'm using, to make these drums, I'm using a flat sketch and a revolve command. And I need now to make a smaller drum. So I'm going to put here, I'm going to use 800 for the loop drum. So 800 divided by 2, that will make the whole drum smaller. So let's just check my parametric skills, and they are better than ever. So this is a smaller loop drum. Let me think a little bit more about how this will work. So over here, we will have 37 millimeter of, let me see here. Yes, this is where the pulley is going to be. So let me see how wide we are going to make this. Maybe we should just do, this is not bad. We're gonna do this. So now I'm planning for the pulley to connect between the loop drum and the programming wheel. Here. This should be 37. Yes. And this is random right now. Like this. So I'm going to revolve to this line, I think. Then we have, I'm going to remove that little extra edge here. I'm going to remove this from the revolve. And I think this will be a good starting point for our drum. And it's called drum. Actually, when I say programming wheel, on all mechanical music instrument museums, they've been like, the staff have been like, oh, you mean programming drum?
Yeah.
And I'm annoyed because I have real drums on the machine. But of course, you call it washing machine drum, and these kind of cylinders are called drums sometimes. It's annoying, but hey. So now, okay. So this is a remnant from the programming wheel. I'm gonna delete this. Yes. I'm gonna delete this as well. On the loop drum, we're gonna have a completely different programming system, and I'm not going to go into that in this stream. So I'm just deleting all the programming holes that we made on the programming wheel, and I am going to completely just skip over that now to get to the indexing dividing head part that this stream is about.
Cut to the chase.
Yes. So we've been trying to be more precise with what the streams are about and getting something done each stream so we can celebrate at the end of each stream. And so far that has led to our workdays being actually really efficient, and we are making strides.
Oh, yes.
It's fun. It's really, really fun. So now you can see this hub is too large because I made the wheel smaller. So let me go and see what I can do about that. This should be another value. I'm going to sheet. You like that?
Cheat as much as possible.
And I'm going to just make a driven dimension here. Driven is when there's already so many constraints. I can say adding this dimension will over-constrain the sketch. Choose OK to create a driven dimension. That means I can't use this number to change anything. It says 378 here. But I can look at the name, D226. So now if I finish this sketch, I can go into this sketch. And I know that this value should be D226. Wait, is that sketch specific?
Uh-oh.
Maybe it's just this one who is... Let me just put something here instead. 200. 300 just for now. Maybe now. D266. D226. Was that the problem? Okay. So now I need to make a parameter on the fly, I guess, to get out of this awkward situation.
And that's something new you have learned.
Yeah.
Parametric on the fly.
It was a very nice super chat from the US who I think posted a super chat because they thought I really would enjoy this tip. So if you're hearing this, I checked it out after the stream and it was a really great tip. So let's see here. 378. I wonder if it's in the same sketch though. I'm just going to try this. So I go like this. And I say, length equals 378. Now I created this parameter on the fly. I did this in this sketch. This is a little stupid, but we don't talk about that.
Don't tell anyone about this, okay?
So look, now I can just hit length. And I have to put it times 2 and we're rolling.
Okay.
So 320. Now you can see my sketch is nice because my wheel is nice. Everything fits together. Not bad, right?
It's time to mirror now, right? I'm trying to be semi-Gretzky here.
Soon. So let's look why we have yellow snow in the...
Urina Unilohai. Is there going to be Wintergatan video about all this? I'm so confused. What is happening now? Total redesign? And yes, we understand that not everybody can follow these live streams on Wintergatan live channel. That's why on Wednesdays we do summary videos explaining everything that's been done during the week. So tune in tomorrow and you will have a recap of what's been done.
Yeah, and you can rewatch. We made one episode so far on the main channel, so you can watch that for the introduction. And yes, total redesign, 3rd time's the charm. Sorry.
I can't let you have all those buttons over there.
Wait.
Things are going off the rails here.
Yeah, I'm getting on top of it. These machines were too similar. They did not work. The one to the right had the same problems as the one to the left. So the idea here, if you're really wondering, is to try to make a digital design file. If the file is promising, we're going to manufacture the machine. If the file is not promising, I'm going to finally be able to give up. So that's the idea.
And finally, my life is complete. Do you know why, Martin?
No.
Slice of Sparta just joined chat here, saying, Avengineers assemble. We're feeling good today. Martin and Hannes 3000. MM3 is coming and nobody can stop it. World tour, save, cheers. Woo! Let's engineer some stuff. I'm with you, Slice of Sparta. Big thanks as always. Love to have you here. Woo!
Always with the enthusiasm. Thank you. Thank you.
Don't forget, save.
I saved as soon as you said it.
And I'm going to do a cheers now because I can. Because I am in control. Cheers, everyone.
I'll also say cheers while I'm CADing here. Okay, so this works. The joint is working. We now have a bearing hub. And here we have some yellow snow in the timeline. There you can see it. What did I use these for?
And we got a follow-up from Urina Unilohai, who asked about the Wintergatan videos on Wednesdays. The follow-up is, wow, you are crazy. But a good kind of crazy, for sure. Love that comment. Thank you so much.
This project is definitely driving me crazy. I have some good support from Sir 3000 to keep me from going over the edge. And I'm definitely going to be courageous enough to give up before it goes too far. In some sense, maybe it already have, but it's so fun right now, so I don't really think so.
And Atsul, first time catching a stream, literally just came from the vid on the main channel. So welcome to you. Glad you joined in here. Hope you can follow along what's happening.
Yeah. So up into the right, you can see where we're at. We're right now CADing the loop wheel. And yeah, that's what we're doing. And we're trying to finish something in every stream. And right now I'm a little bit confused. Sometimes when I reuse other designs, I get all these yellow sketches. And I think I should be more methodical. I'm going to look at each of these yellow events in the timeline and just make sure if I need them or not. Because I think this is a mid plane. So I think I just need to reselect this one. Now it's not yellow anymore. And this, I have to a little bit investigate what all this is. Oh, this is for the through holes. You know what? The situation is different on this machine. I'm gonna just throw these features and see where that gets us.
Joshua Horshier, any chance of bringing back the weather cam? I need to see some nice weather. That was a beloved segment of our live streams when you were in France.
Yeah, that was funny. We should make a new one. That would be funny. So this is all working. Now we're gonna mirror all this. So let's edit this feature. So I'm gonna I do a little bit of detective work. Now this is working. We have no snow in the timeline.
No yellow snow.
That's very good. And we have the middle and we have a rigid group. Okay, so let me do a little sneak preview of how this would look when we put it into the main assembly. And I'm so happy that I can throw this clutter out, delete.
Yes, please.
And the big thing, is that I thought that these pulleys, so that's a new decision. I thought the pulleys would stay on the machine and only take the wheel off. We had a lot of suggestions around that. It's very complicated, and the wheel is not running perfectly true. With this new design idea, I came up with this morning. We can machine these wheels on this rotary CNC machine, and they are on the same perfect center throughout their whole life. So what we ended up with was a lot of these double wheels, like having a pulley next to a side of the loop wheel. So now I'm very, very happy that we actually can remove this. So I'm going to remove that for now.
Totally brilliant. Exactly like Whiskey Heavy here that says, love that these are 9:30 a.m. in my time. Such a great morning show, in my opinion.
Funny. Fun, I mean.
And BFG, I've never spent this much time listening to a person I didn't personally know. I cannot wait to see how this unfolds. Been following since day one MMX. Whoop whoop.
That's lovely to hear. I mean, this is our Rocky moment. You know the Rocky movies when Rocky is beaten down like in the beginning. This is a classical hero's journey if we only can get through it. If we can live to tell the tale on it, 3000.
Oh, we will. Oh, we will. And Dexter says, I think I'm invisible to the channel. And Dexter, you're not. I just don't simply see everything that's been written in the chat, sadly. But I see you now.
Brilliant.
I promise you, I see you.
So when I tried to join this, I saw that I could move parts separately. You see there are some bushings not working perfectly there. And the issue is that I haven't glued all the parts of this loop wheel together. I have to do my homework. I have to get over here and make sure that this rigid group joint is acting correctly. And exactly you can see that the POM bushing here was left out of the rigid group. So I'm going to select continue. I'm going to select them all. And this one as well. Include child components. Okay. Now when I save, wait, I'm going to hide those sketches. Now when I save, an update will propagate here. So you can see the little triangle there. And when I update this, we have our computing screen. No, wait. No. Now I should be able to join this drum the way it's intended to. I join it right there. Now only the bushing goes, or no, everything follows.
Oh, nice.
It looks nice, right?
Oh, finally see it. Oh.
It looks clean, right? And now you can see that I made it smaller, so this belt is too big right now. We're not going to worry about that currently. Okay, so this reminds me that this thing, yeah, that's where we have to cut it off, right? Oh, and this thing actually goes into the belt. Let's see how we're doing this. Oh yeah, I'm stupid. Here, here is where I wanted to join this. Let me redo this. Edit joint. I'm gonna deselect the first one. See if actually gonna deselect both. Delete the joint. Let's join it here. Yeah, now the belt is clearing and it's lining up perfectly with the side of the drum. So kind of if we look at only...
What happened to the bushing down there?
Yeah, I have to find out where that comes from. It's from another design. It's from... yeah. Good one. Look how pragmatic this looks.
I love it.
It's like a nice little washing rack. So the bushing here is outside the rigid group of the programming wheel. Eagle Eye, Hannes 3000.
Oh, thank you.
I'm gonna edit this rigid group, and again you can see that it's not in the rigid group command.
BFG, don't worry, the giant funnel will catch any parts that fall on the floor.
That's true. So let's go update, and the bushing will fly into position.
Let's see this animation.
There. Oh, I missed showing it though.
But it happened. We
I
promise.
I was busy with the sound design.
Chemist says here, I've learned more about Fusion 360 thanks to Wintergatan than any dedicated tutorial vids. Now that's some praise right there.
That is so much fun to hear. Love that. I can also say that these are speed holes.
Oh, yes.
We learned that in the stream earlier this morning. Okay, we have the wheel on place, and now we can kind of see how much space we have here to make this indexing disk. Do you have some... So we're actually ready to go to the next point of the stream, CAD dividing head, and we're going to celebrate this with a mole. Yes.
Waboosh.
Did you have some images of dividing heads? There we go. So...
Can we perhaps enlarge in one here? No, we couldn't.
No.
Get back here.
No, but that's okay.
Went away from me. There
I
we
don't really know how these patterns are, and I don't think I have to really understand exactly. It feels like they add more and more holes outside, and then they have a straight thing. So I think the first step will be a lock pin from the inside of the wheel. So if we go to our loop wheel, I just want to make sure I'm on the correct side. Yeah, the longer side. It's this side. I'm going to create a sketch. See if I can do it on this one. I'm gonna project these two lines. Is this going wrong now? No, this works. So if we look at the dividing heads again, Hannes, you can see that there's a straight line and then a disc with... so if you look at the handle there, there's a disc with holes and then a straight line for indexing. So now what I'm doing is a straight line. The little golden thing sits next to the crank.
Oh, okay, okay.
So isolate this, remove the body. And I want this line to be in the middle, and then I can use the symmetry constraint. So I just click and I say click and click, and that went wrong. So I have to click in another order. So click, click, click. Now it's symmetrical, which means it's in the exact middle. And then I can make it equal length and it should turn black. There we go. But the position is still not. So let's just give it a help line and just make it completely constrained. There we go. And here we're gonna use something that I fell in love with the other day. We're going to use a twist to lock nut. We made a stream last Friday with... We were a little bit happy because it was Friday and we called the stream This Pin Saved Friday Night, which is one of the more stupid YouTube titles I've ever done. But let me show you the pin that saved Friday night. twist to lock pin. Twist to lock pin. This one. So you can see I'm going a little bit. This is actually 0.5 on our to-do list, but I want to start here a little bit. Now we can choose a metric. I want to show this a little bit bigger. Maybe this works for now. An M12 thread, 8mm nose diameter sounds good. So we only have 2 here, and it's just without thread locker. So I'm gonna download this pin into our design. So here's the pin. And then, so this was an M12 thread, I think they said. Yes, can you please let me? Oh no, I downloaded it while being in a sketch. Sometimes that doesn't end well. Oh, it worked. Good. But my browser tree is messed up. Here's another tip for me. Try to keep your browser trees clean. I messed up. I added this to this component, so this becomes a multi-component. I didn't actually want that. I should have been in the main, had it activated. Then I can move it out. But what I don't like with that, sorry for that, is that it creates a move command here in the timeline. So when that happens, I always redo. So I'm gonna delete this thing, and I'm going to delete it from here. And I'm going to make sure that I have the correct component activated while I'm inserting it, because you do not want mess in your browser tree, like I actually have there as well. So insert the same thing. Twist to lock pin. So what are people saying?
The pin that saved Friday night. That's brilliant.
Why did I get more now? Here.
A big shout out to Gizmo White for supporting us. That's really, really kind of you. So thank you very much.
Let's see if I can live up to your valuable trust with this twist to lock pin.
Hannes 3000, make sure all these parts prey on noise. It was a long time now since we did it last time.
Yeah, I don't have the image at the fingertip anymore.
But I have the voice at my fingertips.
Yes, you truly do. Pairing hub mirror. So where is the right hub? Why is the hub gone? Edit feature. It's there. Oh, it's in here. I'm stupid. It's here. No. There's a stand-up comedian, Eddie Izzard, who makes a sketch about you never see in movies people go like, huh? In front of computer screens. And I feel like these live streams are very much like that scene.
But yet people say that they learn a lot about Fusion watching these streams.
Yeah, that is brilliant. So I had this issue before. That's why. Hang on. Left hub. Okay. Got it. Got it. So now let's make these holes for this lock pin. So my idea is to use this indexing idea from one of these spokes. Maybe from several, but let's start with one. That should be enough. Let me locate the sketch. Here we go. So 12. I'm gonna just leave it as 10. And let's make a rectangular pattern, or what someone said, array.
Array.
Yeah, that sounds cooler, right?
Array.
Symmetric. So how many of these pins do we want? My idea is that we won't have to. So they have to be on a very specific. We're gonna use spacing so we know exactly how far apart they are. 20 millimeters. Let's do more so the hand is not. It's not. Like that, perhaps. 22. Or maybe. Ooh, that looks good. No, then the plate needs to be big. 22 is good. I'm just gonna cut these holes out with some bad CADing practices. Children,
Close your eyes.
Close your eyes.
Just tell me the word, Martin. I will put on a black screen here.
Good. And now we're going to join this little thing here. Join our spring plunger. This with this.
Ooh, ah.
Flip.
Ooh, ah.
Oh wait, I choose, of course, the wrong side. Is it on this side?
Do you know what here, Martin?
Tell me.
I got something from Linus Öberg here.
Okay.
Hannes, for fun, I reached out to SKF. I got an answer from them saying that a sponsorship is not an impossibility. Should I just direct them to contact@wintergatan.net?
That's fantastic. We talked this morning about... thank you so much, by the way.
That's brilliant.
That's brilliant of you. Just make sure everyone that you're not I think sometimes if I mention a company, maybe the company gets like 20 emails from fans, and so but this was brilliant, Linus. Please, you can email contact@wintergatan and tell me what person you talk to, because we learned this morning that I'm using American bushings and bearings, and someone said you can download the CAD from Swedish SKF, and I am from the town where SKF was born, which is a very, very, very cool bearing company. So this is very appreciated. So yes, please send to contact. And why did my joint command break, Hannes Paradis? Do you know that?
I don't know, but chat really wants me to narrate a trailer for the Marble Machine 3. That's always, as soon as I break out the voice, people are like, oh, please. I can just humor you a bit here, chat. BJ Kehoe sent some few lines here. So yeah, I will humor you. In a world, one man, one machine, and a battle between form and function. That's all you're gonna get now, people.
Come on now, Martin. Get it done.
Slice of Sparta, reported video for explicit CAD design.
Maybe I just didn't okay the joint. Here we go. Joint is there. And so here's my plan. These the cool thing, I have to tell you why they say Friday night. When you pull these out and you twist them 90 degrees, they stay withdrawn. So this little indexing thing here will stay off. And which means that we can have several of them here. So I'm going to make an array of this component or a rectangular pattern alongside this line. And if you remember, we had 22 millimeters of distance, so 22 and choose spacing and 22. And then this didn't work out. The heads are too large, you see that? So let's do 44, one in each hole, and 4 knobs. Pins. I am a little bit worried about this length. It's not really reassuring, right? It's only 6 millimeters. I would like to index with like a longer pin. But let's leave that for now. Because I'm actually already done step 5, and now I'm going to start with step 4. So let's now make the dividing head plate. Unisolate all. New component. Dividing head. 0305. Dividing head. So when we started to talk about the SQF bush bearings, is these bearings with a flange. So they are super nice, but these are American. And I saw the price and I was like, oh, I can't afford that. I can't afford those. Dividing head. New sketch here. So let's project the holes with the knobs. Which ones? Here. This one, this one, this one, and this one. Let's also project the middle. I think I want to do that from the main sketch. I can do it from here. So let's isolate this so we can see clearly what we're doing. And now I'm gonna shoot a little bit in blind.
Yes.
But what I do understand about the dividing head is that the holes are all positioned on these circles and with different space between them. So you can get a very, very, very precise timing adjustment. So let's take this circle. Wait, how big is the little pin sticking out? 6 millimeter, right? 8 millimeter. Do-do-do-do-do-do. 8. And then we're gonna do different circular patterns. And we're gonna create that sunflower.
Oh.
Is it called sunflower? Jag tänkte på solfjäder.
Solfjäder.
Sunfeather.
Sunfeather?
Sunfeather pattern. Circular pattern. I'm gonna start with this one. And here, we can go back and fix this later. I don't know, 30? 40? 60.
Oh. Oh, wow.
You like 60? Let's try.
Baba boom.
Baba boom. And then we do the next one. So now it's important. I can just like, oh, it starts. That shouldn't matter. But if I pull a line to this one, we do not want a hole exactly here because we already have that setting. Do you understand how I mean 3000? We want all the holes to be shifted towards each other.
Okay, yeah.
For maximum resolution. There's probably some science around this. There is science around this. So now, wait, sorry. So we had 60 before. Let's just try 100 on this one. So here you can see like that this...
Oh yeah.
These circles are not hitting the same...
Yeah.
Hundreds maybe a lot. This is also good. 80. So if I pull a line here, I'm kind of in between.
Golden ratio, chat is saying. Scarvara, Flooper, golden angle. Lenny Payne, golden angle, 137.5 degrees, baby! Use the golden ratio.
That's probably very smart.
Yes, there is. You should use Fibonacci numbers.
Oh, everyone is onto this.
Thomas Klinkenberg.
So, but what I don't understand is it the angle of the first hole or the number of holes, and also the distance between them. This is what I don't understand. It would be cool to use some Fibonacci numbers.
It sounds cool. Yes.
Yes.
I agree with that.
So let's do 100 on this one. So I'm just going to finish this now, and then I'm going to revisit. Can someone send a sketch with the Fibonacci numbers explained, and think for dummies? So not too much text, just show like where you mean the Fibonacci numbers, because I don't understand. And upload it to the Dropbox in the timing indexing folder. So here.
Chris Georgie, you want co-prime numbers of holes if you're trying to get useful adjustments. Co-prime numbers. Yeah, I love that sound.
Because of Optimus Prime?
It sounds badass, co-prime.
So let me just take a random sample here. I'm just gonna point this line. Oh, this is very bad.
Yeah.
Look what I did.
That's horrible. What have you done?
Look what I did here.
It's exact.
This is exactly what we want to avoid. Here is better.
Yeah.
So yeah, the system everyone is suggesting will be the correct one. Meanwhile, we have the dreaded crash of Fusion 360. So let me hit up a pause screen while I'm restarting the program. I had even numbers also. I'm going to add some uneven numbers or something until I've learned what people mean.
Co-prime numbers are related to pi. One screw loose can't see the Gretzky's for the trees.
So, Finder. Let me see if I manage to force quit Fusion.
I will take this time to just say cheers to both you, Martin.
Good idea. Cheers. Cheers
and to all you out there watching. Okay, Mike Perry, Hannes, can you say Autobots, roll out. Roll out. It's a hard one.
Solid 7. And we are back.
There we go.
Let's see if we have a recovery file for the thing. No. Let's just see what we have lost. You very seldom lose things.
You don't want the numbers to have prime factors in common.
But they're also on different diameters. I think I'm gonna use someone's sketch on this. There will be a brilliant sketch, I guess. So this use 60. So then I think the next one should be like a little bit more odd. Let's try this one. Oh, by the way, I want to show a tip for any Fusion 360 users. When you have multiple circular patterns like I have, it's hard to edit them afterwards because you only see one here. But if you hold for a long time, and then you can choose here, and after that you press right hand, then you can access edit circular pattern. I'm pretty sure someone else there had the same issue sometimes, and I found that out. Instead of 80, I'm gonna put 79. Or 70, 77 sounds even more. So let's do that instead. And let's just take a random sample here. Look, this is anyway a little bit different. But people will figure it out. Save.
Bing over Google. Numbers of holes per row should have no common divisors. I.e., there should be no number that can divide the number of holes in both.
That makes a lot of sense because that would mean that some holes would line up along the circle. So that one I did understand. So let's just try some 123, some random stuff that's a little high, 111. I'm not sure. I can of course check. I'm not sure how to know which numbers can't be divided by two numbers. This is I ditched a lot of math in my life, a lot of math classes, and I regret that now. The math teachers were basically math is so cool. I don't understand how they managed to make it so boring in school. Can you relate to that, Hannes? 134, probably.
This is so above my head as well. You seem so smart in chat as well.
There's a lot of people who I think we are way. What did we do? We pull out the calculator the other day when we had like 17 plus 54, and we just looked at each other. Let's pull out a calculator.
We need it now. 60 and 77 are co-prime, so nothing will line up. Okay, what does that mean?
Okay, so here we have the basic thing. I'm going to revisit this off stream, but I am going to show you.
Make them all prime numbers. You can find a list of prime numbers online.
Oh, that's a very actionable tip. So here's the disk. And here's the whole kicker. We're going to connect this to our pulley in the middle here. So let me pretend that the pulley is 147. And we're going to make... So let's add 4 screws that will go into the pulley. M8, 8 millimeters. Fusion is getting sluggish. Doesn't like all these circular patterns. I should not. So I made a big mistake here. I should have made the circular pattern in the feature instead. Okay.
Do you want a big list of prime numbers?
No, not now.
Okay.
I want to show the function first, but maybe soon. Maybe soon. I just want to show where I'm going with the design, and then the actual hole placement can be a little bit later. But I made a beginner mistake. I should not have done it the circular patterns in Sketch. I should have done it in the features. So let's do this. Let's do 40. And now finally I can make an extrude. So let's do a plywood thickness 18. This looks pretty cool, right?
Oh yeah.
So where is our thing? Here's our thing. Now we're starting to get it right. Check this out. We have these knobs here, and they can be retracted and pushed into any position here. And this position, it's always on all of them. Now I'm gonna rotate this disc, and we should be able to see. Oh, it looks like we did. No, I think we maybe did a little bit okay.
Love the confidence.
I am going to fix this. So if I rotate this disc, yeah, but check this out. You can see there's the third pin aligned. There's the fourth pin aligned. Here's the first pin aligned. Third, fourth. But this is not well executed. But you can. The idea is that we can shift this disc over a very, very small degree and insert a pin at a new place. See?
Wow. This is mesmerizing.
It will be cool. It is cool, but it will be cooler when I'm when we have a system for the holes. So let me. I think this should be plywood as well. No, this will be so mega strong. And I'm going to replace these pins with a pin that protrudes further into this disc. I don't like that it only sticks in 6 millimeters. I think it should stick the whole 18 millimeters in. Oh, but I know the pins. Wait. We have these ball plunger stuff. So let me just go and get one of those. We use them for the cross bracing on the machine. So spring loaded plunger, I think that's called. Yeah, these ball style weld mount, twist to lock T-handle. A quarter turn of the handle lock these plungers in the retracted position. The T-handle is easy to grip. Twist to lock, a quarter turn. This one is nice because I think these are bigger. But how do I get this to stay in the plywood? Nose diameter. Oh, this is huge. But this is what we want. Let's bring this one in. Product detail. No, I'm stupid. Took the wrong thing. Where is back?
Alexander Sola, shouldn't the holes be 8.1 millimeter or 8.05 millimeter to allow for clearance from the bolt, which is 8 millimeter?
Yes, probably. I am doing this kind of low resolution. If you mean these holes, here. Okay, yeah, I see what you mean. It's a good point. So look at this plunger. It's plunging better. It's plunging much better. Do I need to hide this? I do. This is not. Look, that looks cool.
Yeah,
doesn't it? It doesn't sit there, but that's a later worry. I just wanted to show that this feels like better. So now if I show everything, you can kind of see like this. And then if I add our pulley, so let me join this also with a joint here to here. Actually, I'm gonna delete that. I don't want to import this. I want to change this pulley a little bit. So I'm going to break the link. So if you check in the browser tree, there's a link here. And I can choose to break link. That means that we get the component in the design instead, and that we can play around with it a little bit.
I just want to show you quickly here.
Yeah.
Chat has been recommending taking a look at gear cutting indexer.
It's the same thing.
It's the same thing.
Yep. This is a dividing head is used to cut gears as an indexer for cutting gears. So it's called dividing head, it's called indexing plate or gear cutting indexer. So now let me just find out. Oh yeah, the program crashed. How far out we want the pulley to line up with the belt from the top wheel here. So from this surface, from this face to this face.
Oh,
This is a glitch. Oh, it worked. 42 millimeters. Thank you. So let me join you with you. Let me flip you. And let me offset you 42 millimeters. Does that make sense? Because if true, we're in a bit of a spot of bother here. Oh yeah, we should put the indexing. Okay, so now we have to solve how to actually compile all this. Can we put the indexing plate on the inside or just move everything in? Is the belt even clearing here?
A lot of people are wondering how the pins can be reached.
Yeah, through these holes is my idea.
Through the spokes.
Yeah.
Yeah?
Because I don't want it to stick out on this side, because then it will be in the way for the belt.
Yeah.
But I am a little bit in a spot of bother here. I have to figure out where to put the... Either I need to just move everything... Yeah, I have to just move everything inwards. I think 18 millimeter. I guess this is 5. Let me just check this. From here... I think I have to give 18 millimeter of clearance. So let's go back to the first master sketch. And let's... let's take off 18 on the width of the loop wheel, which is okay. 18 to give space for the indexing disk. So I have to edit the revolve feature. I should show maybe big screen. So we remove that. And we'll see the mid plane. Here we go. We have more space now, as you can tell. Because this is now lining up correctly, I think. Delete joint. I have to redo this. Flip, and now 42 plus 18 this time. Minus 42, minus 18. Boom. Right, Sir 3K.
I am watching in excitement to see how you're gonna figure this out. This is exciting times here.
So now when we look from the top, you'll see that the belt is have clearance, and we have this here. But we still haven't figured out the bearings. So this is what's missing from this.
So you're gonna reach your hand in between the spokes there?
Ooh, that's a little harder now, right?
And attach the pin?
Okay, yeah, so this is a good point. You can't put your hand in there anymore. I forgot about that. Now I realize why people are asking. So either we simplest stupid fix would be to just make this plate a little bit smaller. So you actually can reach in. And fill that up with holes. Kind of looks better as well. You're not getting the leverage, and you will get less. This looks pretty nice, I think. So now you get your hand in
Now
there.
you can reach.
Yeah.
Okay, we can take a deep breath now, chat.
This is why we have a digital model.
Yeah.
Imagine if I would work at that, order this piece to be machined by Austrian precision mechanics, and then just
Cue angle grinder montage now.
Yeah, I'm wearing the angle grinder I'm wearing my scars like a crown, Sir 3000. So before I go into that, I just want to check out what happens with the bearings. So let me take this away. So this bearing is this bearing. Nothing new there. Why are these holes covered?
Kasper Christensen, make it 2 plates with sun gears in between, then rotate the sun gears to index. Sun gears?
2 plates with sun gears. That sounds like more moving parts. I'm gonna cut this pulley. I'm doing this a little bit bad. So I don't fully understand, but sun gears looks like, it sounds like there's too many moving parts. I'm gonna cut this to here, but I'm only going to cut the pulley.
Chris Georgie, the simple fix is get rid of the disc and just use a single arm with tangent screw. Huh?
With tangent screw. So a single arm like the one I had from the beginning. Because we can also use this outer perimeter here. We could also move the holes here. And we can have a lock pin.
Oh yeah, it's like with sextant.
What is that?
That kind of solution, right? Let's see. Like you have on this one, right? Screws to change the gear.
Ah, that's interesting. Well, is it? Huh. Okay, so you... So first of all, we would still need a disc.
But perhaps not a complete big disc, right?
And then we would need to manufacture those threads in something. So what material would that be? And would it take forever to make big adjustments? It would be extremely precise. But the disc would still be there. We're not getting rid of the discs.
Or perhaps it can be a smaller disc. Or am I completely wrong there?
No, so I want like the smaller we make this disc, the less accurate the adjustments we can make. And of course, the gears are already reduced by 1/8, so the measurement is only 1/8, so it's already pretty accurate. But what I'm thinking right now is instead of the disc to just have one arm and the pin from the outside and some kind of little flush pin.
And the same guy here, Chris Georgie.
Yeah.
He also sent a big, nice article on Discord that you can read in your spare time.
Cool.
How this is manufactured and works.
It
looks so cool. Oh my god.
Oh, the
sextant.
sextant.
Oh my god. This is engineering porn right here. I can't show it on YouTube. It's too good. We get flagged immediately.
Let me... Because I don't like the leverage here. I don't like let me think of something else. Let me just hide this dividing head, and let me take some inspiration from the single arm idea. Single arm. So and the pin from the outside if we find the right pin. That's a big if. So let me project this. So this will look. So we're back where we started, basically. Not
Oh no!
No. Not really, because this is happening on the. Actually, not really.
You probably only need a Pac-Man worth of a circle. Fine. Thank you. I understand that.
With a mouth. So I kind of like this idea because it leaves the spokes visible. We're doing form from function absolutism, so it's not that we care, but we still have free speech. We're still allowed to express opinions about looks, even though I'm trying to not. Let's make this vertical. So here would my point be, we could have 2 rows of holes. I'm just sketching this a little quick. And 2 different pin locations like this. 8. Oh, we can put the pin from inside here as well, but I want to move it from the in. Okay. So check this out. 3,000. 3K.
Okay, a lot of people are agreeing on a comment by David E here. Martin, you don't need to adjust timing all around the programming wheel. You just need to be able to adjust the timing between 2 teeth of the belt. To adjust more, just skip tooth on the belt.
So, in theory, it's true, but every time when there is like this, just do this or just do that, you just like think of the implications on a live concert, because this is going to be set off the machine. So when we change this, we already need a little mark on the belt and a little mark to know that we're on the exact right teeth to put the belt back. And then you don't want song 3, belt color green with tooth purple, plus the setting here. Plus that will take more time, like on stage when the audience is waiting for the next song. So in this system, the technicians can set the wheel to the correct position before it's coming back to the machine. So it takes less time to change the song. And instead of having dual settings on 2 places, we have 1 setting on 1 place. So that's why I think it's worth it. But technically, you're absolutely correct. That would be sufficient adjustability range. Absolutely correct. I kind of like this more when it's more air through it. What do you think?
Airflow, good.
But there's one burning issue, and it's how do we keep this from sliding out of the shaft? That will be the frame then. Actually, that will hold it in place. But we are getting the pin sticking out issue when we're doing it like this. So how can we fix that? So the idea here, which you probably already grasped, is to move these holes to the outside ring. But this pin. I can move this whole wheel to the left, but I'm missing programming surface then. It's a trade-off with programming surface. But there are these kind of tight pins. Let's look at some more pins. There are so many. Spring plunge pin. So these pull ring retractable plungers are like sticking up very little. You see that?
Yeah.
Let's look at some big stuff. Are these the biggest? Twist to lock pull ring retractable spring plungers. T-handle. Low profile knob style retractable spring plungers with hex drive. Check this out. $100 million for one? No, 12. What? How does this work? Installed by hand or with a hex. Retract the nose by pulling the knob. These spring plungers have a long nose that provides a large bearing surface to handle side long nose. Let's check this biggest one. Everything is in metric. Extended length. Did I take the biggest one? Something feels wrong about all these. I think there's a simpler solution somewhere. Oh, this was chunky. I like chunky. Check this out. But this is my beef. It's only 6 millimeters. No. Let's go out and look how this looks. To just change perspective a little bit, because I'm a little stuck on this right now. Let's just go and update it in the main assembly and just have a feel for how things comes when they're out here together. Okay, I forgot a rigid group for this one, as you can see. this looks correct. So let me just update. Oh, I don't even have one. Let's just rigid group the whole thing and try again. So I was liking the fact that you could access this so easily. So if we had a pin from the outside, so there's different ways. I can make the drum, I can push the drum to, I can make the drum shorter, because if we actually look at, yeah, this is good while I'm getting some, but you see the hi-hat, you want to start to use this. This is what I mean. I need programming tracks already here for the hi-hat. So I can easily make the belt clear, but then I can't play the hi-hat. This looks cool though, the pulley and this. Like it. I like it a lot. This is actually super simple. Also, maybe my top feeding idea comes back here. Just to pin from the top. Just pull this out and pin from the top. We're back where we started. 3000.
Yee-hoo!
So the difference in putting the holes here and having a disc in the middle is that when you put the pin from the inside sticking out, the pin can stay where it is. Oh, but this maybe just go back to the. Maybe just go back to the. Let's look how that looks. I think we can find it here. Maybe just go back here then. But the thing that I don't like is that a small adjustment here in the center becomes a huge adjustment. No, wait, I'm stupid. Small. Huh. Wait. What if I make the... instead of spokes, that layer becomes a disc. What do you think, 3000?
I am loss of words. And chat is indecisive about what to do. Everybody's shouting different solutions.
Okay.
It's chaos right now.
Okay. Oh no. That's why I love these streams. Yeah, so maybe I have to explain my motivation. I want clearance for the belt. So this belt, I have to move this belt over there. And let's hide this belt. So what I'm trying to design for here is clearance for this belt. Right now, we have nice clearance. This looks awesome. We can ignore this belt for now. So I'm just trying, and I can pull everything to the right as we're looking at it, but then I'm losing programming surface of the loop. I don't want that. So What I'm trying to find out is a clean, tight, simple, reliable solution. Wait, what did I say? I said that we're gonna make this adjustment off the machine, which means we're not in a hurry, which means we can countersync. Okay, so this makes a big difference. We can just bolt a bolt through and put a nut on the other side. We can countersync. We can move the pin. Since we're not in a hurry doing this, the whole like pin idea with might be overkill a little bit. We can basically just move a bolt to our new position because there will be plenty of time. There will be a whole song of time to change this setting. So like go back to basics. I would say
Dexter says, how do you make the timing adjustment off the machine?
You know which hole it should be in.
Okay.
You have a little mark on. You have to check it like in the music studio, and then basically you have marks here. So good question. Basically, it says on the disk here, it says like 120 BPM. And an arrow to the hole. So basically, then it should be as simple as putting threaded inserts in this part and a countersink bolt in this part. That's low. That's really low. But if we do that, yeah, and the reason why we would rather do that than having the arm is because with the arm we would need to put 1 million threaded inserts, and over here we have screws. Now the disc is the better option, and we don't have to stretch inside. This is good. This is okay. We're getting there, everyone. Through this were like the dead marshes, right? We're almost seeing the mountains now. I'm trying to share 3K up with some.
I'm rebooting over here.
Since we're now doing all the adjustments from the outside, we do not anymore need to stretch our arms in here. So we could actually go back to what I liked better, which was the big one. Still not with correct numbers, but anyway, 560. Boom. So we can have this and we just countersink all these holes. That's going to be fun. It's going to look fun. And then we drive a bolt through this that hits threaded inserts here. We can use yeah. That is a nice idea because then it also clamps together, which will running over my headphone cable. So it clamps together, which will hold it like rigidly. Nothing will rattle. It's brilliant. What's not brilliant though, that's how I sketched this. So I will do that. But are we running over time, Hannes?
Oh, yes, we are.
Oh, but you're the timekeeper.
Well, you're still on 0.4.
I'm still on point 4.
Yeah.
Yeah, I think I want to finish this, but if you feel like it, you want to call the day. Don't feel like an early quitter.
No, I'm not an early quitter.
No, never.
You know what? I'm gonna go and make some food.
Yep.
If you're still here when I'm done, perhaps I will rejoin.
Yeah. So since I want to take this to completion, and now I know how I want to design this, I feel I should just go on. So people in chat just have to excuse.
Yeah, and all you people just shouting that this won't work, then tell how you should make it work. You can't just say this won't work. Why won't it work? Why?
Why? That's a good point.
We have 2 new suggestions in our Dropbox also.
Fantastic. So this sketch is basically almost rubbish. I'm gonna delete it all. Let's hope Fusion accepts this command. Yes.
Foldy 1 Pyrus. To change the speed of the drum, you need new gear ratio. This part is wholly unnecessary.
Yeah, I think this part is wholly misunderstood. It's not about the speed, it's about the location of the drum. The gear is up here. It's the driving gear for the next thing. I think maybe it's hard to say. The gear I think that you're talking about is this belt. So it's another connection I think you're talking about. Go and make some food, 3000.
Chris Georgie, engineering tip: state the problem to be solved and then show how the solution solves the problem.
Do they mean in communication?
What are we trying to adjust? How much range of adjustment is needed and at what resolution?
Yeah, so everyone who is confused, go and watch the timing clutch video of the Marble Machine X project. This is what we're building, but with another design. So that video explains exactly the part we are creating in this stream.
Timing, not speed.
Position. Yeah. Relative position. Maybe we have a lot of new viewers who missed the beginning of the stream. Relative position between this and this drum in different musical tempos. But this is brilliantly explained in the timing clutch video in the Marble Machine X series. So that's the perfect context actually for what we're doing. And then when you come back, maybe I'll make some progress.
So yeah, chat. Perhaps see you later.
Otherwise, thank you so much for a lovely day, 3000.
Right back at ya.
It was fantastic. So do 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 do. So first of all, I'm going to get some threaded inserts. I don't really like the hammer in inserts. We could even use a bolt on the back side if we really want to keep it. If we really want to keep it. Because that would index a little bit better. No, I think I will use my standard go-to threaded inserts there. I don't have to CAD it. Let's do the disk first. And then we can use all these tracks. This is great. This is great. Our pool is not here anymore. Okay, I'll make those holes later. So the mistake I did before is that I was using the sketch and I made a circular pattern in the sketch. So now I'm going to make circular patterns with features instead. So that's a good lesson in how to make Fusion 360 just behave so much better. We do not want these 4 holes. Going to cut some holes in this later. So 18mm. There's the disk. And let's isolate this. So here's what I mean. I'm going to cut this 18, boom, boom, boom. So I won't be reading a lot of chat right now, and we don't have 103,000 anymore. So if you want to leave suggestions, please send them to the Dropbox links that you will find on the website. Because right now I have a clear idea of how I want to proceed, and I'm just going to use this to get this to-do list done for this stream. I'm just gonna push on until my idea is done, and then hopefully you will like it. And if not, you send a suggestion to the Dropbox. So currently I'm not seeing chat, so I just wanna stay on and finish a third task for this day. So I'm going to chamfer this hole because we do not want anything sticking out for the countersink bolt. So let's say something like that. And here's the kicker. Now I'm going to make a circular pattern of a feature, which is much better for Fusion compared to making a lot of circular patterns inside the sketch. So I'm choosing this hole that I just cut. And I also want to choose a chamfer. So now I've chosen this. And now I'm going to say, and then I can go back here later and do prime numbers and stuff. So let's just do quite a lot. 40 here. They're going into each other a little bit. That looks cool. And then we're gonna do the same over and over again until this whole disk is filled. Yeah, we need... Okay, yeah, we can't get our arms in, so I can't have a nut on the other side, so it's definitely going to be a threaded insert. So let me do an extrude and hold in here until I get the profile. Perfect. Let me do 18. Boom. Let me just do all these. Profile 18. Boom. And I'm doing this in different extrudes so I can circle pattern them differently later. And it's good because then we have different numbers that we can go back to and fix our prime numbers and all that jazz that you taught me in this stream. That is a little bit too complicated for me to learn on stream, but I'm gonna learn it afterwards. And if someone is confused about what this disk should do, then I'll reference you to the timing clutch video of the More Machine X project, as I mentioned before, because that's really making it ultra clear. So I'm gonna revisit this pattern. Probably I do not need this many holes at all. Once I see like what kind of resolution I need. I just need a couple that is offset against each other and I will be more than fine. But in order to just complete this task, I'm just gonna complete this and then revisit it later, which I found is a design structure that always works for me and gets the job done in the end. So now I'm choosing, I'm just gonna group these like this down in the timeline. Like this. So now I'm choosing the second row of holes and I'm circular pattern this in the body here. So let's do some odd numbers. I'm not gonna get this correct now. It sounded like Hannes was seeing a lot of maybe frustration in the chat or something. I haven't seen it, so if people are frustrated in the chat, I hope it's not too much for everyone else. I'm having so much fun today with this, and right now I'm just trying to get to the last part of the to-do list for today. Circular pattern this, like a little bit more, maybe 55. Some crazy amount of numbers. Too many pattern instances. Let's go optimized. There we go. Circular pattern this. Boom. Random. 66. Boom. Circular pattern this. Boom. 52. Nah. 69. Yes. That's okay. Circular pattern this. So I'm happy I could show you the more proper way to repeat something a lot is to do circular pattern on the feature out here, not inside the sketch. It will save you so much time when working with Fusion. $92. I'm just exaggerating a little bit for fun. It looks cool. Then this last little group. Circular pattern. There we go. And of course, there will be impossible here to write which setting. So I can't have this many holes in the end because we need to know kind of what all the holes are called. But I kind of like it anyway. Like this. Let me go get a bolt. Why not? Why not? Unisolate all. This old thing. I'm gonna throw them away. So if there's a lot of great suggestions in chat that I'm not seeing right now because Hannes is not here, please make a sketch and send them to the Dropbox link. And we go through everything. So far we go through absolutely everything. We try to also go through everything on stream. We're going to make dedicated episodes because there's a lot of suggestions and it's wonderful where we're going through all of that. It looks a little ugly right now. I think that's fine. Let's go and get a bolt. So screws and bolts, metric. And where's head size? Flat head. 8mm. No, that's length. Let's do M8. I think that could probably M6 maybe will save us. I did M8 in the hole, so length, I wanted to go through 2 pieces of plywood, so 18 plus 18, 36, 40 is perfect. Let's not exaggerate. 35 is enough. 35 long. This is the one. And now it's so nice that they gave you an option here to oh, but not now. Some of these are available without threads. Maybe the zinc plated one. Yes. 3D step, no threads, which is better for the performance of Fusion, less faces and stuff. So adjusting this thing, it would be child's play. It would be to remove this screw and put it into the next position. We would need to have numbers and stuff next to here. So let me now just for the sake, put it into here. Boom. And this is not how you screw in a screw. That's how you screw in a screw. And you can see I messed up the countersink. The countersink is too big. That's all formalia. We are getting somewhere here. So let's create... I'm gonna now cut the holes for this pulley. So let's create a new sketch here. Boom. Let's project this pulley, or I actually only want these 4 holes. And I want to cut those. So we have lost our Lord and Savior Hannes 3K for this evening. I am soon done with this task. I just wanted to take this into completion. So these are going to be the 4 bolt holes minus, can you work with me, minus 18? Minus 18. Just check objects to cut so nothing else is in there. Perfect. This is good. And then is the question about sliding, if this shaft will be, no, this shaft will be idle. So this is probably the remaining question, how to get a bearing in here. To keep this pulley. Of course, the pulley is made for POM. PM is a great bushing material, but I would prefer if there were bearings in this. So that's the last piece of the puzzle here now. Because this flanged huge bearing, I don't think it fits inside the pulley. It almost fits inside the pulley. That would be cool. But it's a little bit stupid. So let's go and get one of those flanged bearings. Insert, McMaster Car component. I love this. Flanged ball bearing. These. Metric. So I'm just repeating that I can't see chat right now, but if you have great suggestions, just leave them in Dropbox. I just wanted to take this into completion for this evening because I'm very close. Shield. The two said shielded bearings look like dust. I think actually I don't need SAD, but never mind. Oh, these are only 6 millimeters. That is very handsome. Let's take this one. No use in beating around the bushing since it's a bearing. Oh, I'm trying to make jokes and Hannes is not here. There goes my jokes. Here we go. Join this beautiful flanged bearing right here. Not even gonna cut it open and just what? Ah, for housing, I read wrong. I took the wrong bearing. Sorry, people. Delete. I checked the housing measurement. I should have checked I thought it was a little bit small. Flanged bearing. Flanged ball bearing is always giving a better search result here, apparently. Flanged ball bearing, metric for shaft diameter. Oh, this doesn't exist, this type for the big ones. Okay, so then we're going to put normal bearings inside, which will actually work better because we can machine it from there. Okay, I got this now. No, this doesn't work. So let's go for ball bearings. Metric. And here we have the big ones. Okay, I didn't know that. But here's a flange with retaining ring. What's that? Shielded with retaining ring. Ah, so you can put it in the middle. No, I'm going to just have standard. Like big, really big thing. This is okay. Do, 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 do. So often when I design, I revisit stuff, and we're so early in this project, so the exact choice of bearing here and the exact, I'm gonna put it, wait, I wanna cancel that because I wanna join it with a joint. So we're not really at that part of the project where I finish CAD stuff, like choosing exact bearing and stuff like that. This is more like I'm reminding myself that I need to cut out space for this bearing. So if I isolate this and this, we kind of need to do something like this. Yes. Projecting the bearing. Boom, boom, boom. Oh, I'm still in the sketch. Okay. Okay. Here we go. Hiding this body. I want to take it to an object, to this object right here. Awesome. And we're going to show this, and we're going to cut, and we're going to cut only the pulley, which we can do by hiding that. So here you can see now the pulley has like a bearing seating inside, and there's the bearing, something like that. We're gonna make something similar. On. I have to solve this a little bit nicer later. Anyway, these needs to index to the shaft, and they are not spinning with the shaft when they're being. So I want them to be able to turn freely on the shaft, and isolate all. Show this. And we are actually getting there. So I can just countersink this to show for myself again that here's where the screws are going in, where this pulley is attached to the big disc. And my friends, let's have a look at how this looks in the big assembly. We had 3 awesome streams today where we finished a subject in each stream, and I didn't want to let this one go until I felt I had completed this. So let's hide the sketches. Still a lot of tweaking to do with this, but I feel we are close. Ooh, I can build in the bushing in this thing. So let's go over to the main assembly. So if we look in our to-do list, we have actually CAD lock pin inside. We did that. So let's, and CAD pulley, that's what we have started to do. And now we're on the last step, step 7. Wait, that's the wrong one. So let's upgrade this here. So for any new viewers, normally we are reading chat. We have lost our chat reader for this last part of this stream. Hannes 3000 is not with us right now, and I'm just racing to finish this. So if you have suggestions, please upload them to the Dropbox link on the website. And same issue that we had the whole day. This thing is not following the other things because I forgot to make the rigid group. So I'm going to choose a rigid group, include all the child components. Now I'm telling Fusion, treat this whole thing as if the parts were glued to each other, because they are jointed in a rigid group. So when I now update over here at the main assembly, you'll see the little disk fly into position. And here's my point. This countersunk screw is not in the way for the belt. It doesn't go outside there. I have to hide this belt. So when you look at it from here, and that's exactly what I wanted to achieve. So here's one last little thing. I just realized that we can create a bushing. Yeah, we can. Oh, because this is great. So let me just, because on this side we already have the perfect bushing right here. You see the POM is against the metal right there, the black cylinder here. And I just want to replicate something like that on this side. But this pulley is machined from POM. So we can put the bushing into this pulley. So let me measure how far it is from there to here. 8 millimeters. So that will be the last little thing before I can whack this mall for today. Let's head over to this thing. And let's just, with some dirty tricks, add 8 millimeter thick bushing here. What happened now? Project. Oh, my sketches are invisible. Always. So here, let's make it 40. And let's go out 8 millimeter. And let's join, because I want this to be part of the same machining operation. Maybe that's fewer parts, a little more expensive maybe. I don't know. It's fine. Let's have it joined for now. Let's also make this component black because it's POM. Here we go. I'm saving this. And now when we update over here, you should see this little area here filled out between the fork and the wheel. Let's update this. I am hearing something. You come in the perfect time to finish the stream, my friend.
Have we solved every problem in the world?
Woo! Oh yes, we have.
Oh!
Have you ever seen a more beautiful disc? The chat is excited. They're saying they love the solution and they're very happy that we've been reading chat the last half hour.
Great, love it.
So let me actually say that we have mounted this to the frame. Let me finish by just showing these 3 parts that are the parts we have. All this have been CAD'd today. This is the 3 live streams we made today.
It's insane. Wow.
Yeah. Hype man is back into the building.
Yes, finally. Got some perspective and like now, wow, we did some actual genius work today. Whoop, whoop, whoop.
So that's great. And then if we add the timing belts, where are you? Where are you, my friends? There we go. I'm stoked about this. It looks a little bit crazy because it's very early days on everything and it's a lot of things just marking. But the fact, check this out. Are you ready?
Please.
When we want to change songs, we remove the belt. We remove this. We remove this. They go and reprogram it. Loop wheel comes back. Programming wheel comes back. Belt goes back.
Ragadish. Woo!
So yeah, I told everyone in chat that we were not gonna read chat the last part of the stream, but so now we have mounted it to the frame. Let's just whack that, Mole.
Oh.
And everyone, last Mole. Yes. It's been a lovely day. Thank you, Hannes 3000, for coming back and finish together. Thanks to everyone who sent all the suggestions today. We got a lot of work done today. And sorry, everyone, for not reading chat the last part of the stream. I just wanted to finish the task. And I'm going to look at your suggestions that you post to the Dropbox.
Whoop, whoop, whoop. You know what? It's been an amazing day. Take care, everyone. And we'll see you in the next one. Take care, everyone. Bye.